quizzes tonight, no exceptions. Make sure you get that done. So, guys, the day after a quiz, like tomorrow morning when I come to work, I'll put the grades in, and I will release the answers so you can go back in and see what you got right, wrong, and it gives you the reasons. Just, you've seen it. So I forgot to do that first quarter for the first few quizzes, but I have since. But I'll start remembering when I record the grades to unlock so you can see it, okay? And then Monday, we're going to have a work day again. This is coming up Monday. I think those are really good for you. But guys, let's use them for what they're intended for. Like, especially this coming up Monday, nothing's going to be open. There's no quizzes or progress monitoring stuff. There's nothing you have to get done except catch up on homework, notes, ask for help. I walk around and bother you all on those days, just hoping somebody's going to need my help, and I'll find something to do if you guys don't need me. But please, you're never bothering me. I want you to ask me, how do you do this? Or I don't understand how you got example of it. It doesn't have to be in the homework. It can be notes, anything. So again, I keep saying this, but keep track of what you're not catching on to. Maybe it's rounding, whatever. And we can work together on those work days. It's a great time for you to have me kind of one-on-one, because it doesn't seem like many questions are getting asked. So maybe you guys are all fine, but start using me as help. I'm happy to help you. Today's lesson, there's nothing new in it from what we did yesterday, so that's nice. All of you were here yesterday, so a lot of this is going to be familiar. So the notes are pretty short, and then you'll have a lot of time to work on homework, okay? So let's get started. First thing we are doing is graphing. We have f of x, and we have g of x. They already set up a nice table of values for us, and so we're going to complete the table of values and graph it. Now, I pulled out yesterday's notes to kind of show you, here's what we did yesterday, here's how it looks today. And example 3 yesterday, same exact example, okay? No talking. So here's another little speech I want to give you. We've been doing these by hand a lot, and then I keep saying, or you could go in the graphing calculator. When it comes time for the homework, I'm going to do one problem with you by hand, and then you can choose to use the calculator or do by hand. It doesn't matter. So I'm going to remind you what by hand means right here. As far as doing it in the calculator, I'll remind you of that too. And there's going to be certain times that I say, oh, just use the calculator for this one, or it's faster to do it by hand, whatever, okay? Let's do this one, and then I'll come back to that thought. So I'm going to plug and chug through this chart by plugging in here. Now, there's no part of this that says you have to show this work. I'm just showing you the work that I'm doing. I'm plugging -2 in for x, and when you plug a negative in where there's already a negative, of course it becomes positive, right? So that would be a 4. So -1, where there's already a negative, becomes a +1. Anything to the 0 power is 1. And then let's remember how easy it is to do the other two numbers. Once you have -2 and -1, or once you have 1 and 2, depending on where you started, all you have to do is flip it to get the one you're missing. So all I have to do is flip 2 to get 1/2. Flip 4 to get 1/4. That's what makes it almost faster to do it by hand for these, okay? So let's go ahead and put these points on the graph. The k value would be 0, so we have a horizontal asymptote right here at y equals 0. I always put my asymptote in before I graph. It makes making these little points so much easier. So -2, 4, -1, 2, 0, 1, and then I can just quickly graph those other two. These are less than 1, so they're somewhere in that little box, okay? So I don't care how you break it up. We just know the behavior of the graph is it gets smaller and smaller as it reaches closer to the asymptote. And there is my graph of f of x. You might notice I always try to, I think, I do, make my XY chart the same color as the graph. So like if you're looking at my notes quickly, it's a good visual. If you're not using different colors, totally fine. But I do recommend you label the graph. So this one's f of x, and then you'll label g of x. So just like yesterday, we just plugged and chugged through here, put our asymptote on there, and then here's that purple graph that I graphed yesterday. To do the g of x, it was all we were doing with this one was left 2. So it was so much easier to just go left 2, left 2, left 2 to all our purple points, and that gave us our green graph known as g of x. But anytime there's a dilation, I don't like to do, it's just so much easier to either go into my calculator, which I'll show you how to do in a second, or just to plug and chug, which is what I'm going to do right now. I'm going to just plug right in there. Negative 2 times negative 2 is positive 4, and I get 16. Negative 2 times negative 1 is 2. Anything to the 0 power is 1. And then remember, you just flip these. So that'd be 1/4, 1/16. Same K value, right? The asymptote is not changing here for either one. And if I go to graph negative 2, 16, that's off the graph. So I'm not going to bother graphing it. Okay? It's okay. No big deal. Negative 1, 4, 0, 1. And then we have those two little fractions. I mean, they're somewhere in here. Who knows? It's a rough sketch of a curve, so just know it's somewhere in there. The graph isn't perfect. I should be able to see that your y-intercept is 1. Why is the y-intercept 1? Because don't forget, when you have your equation written in this form, this is your y-intercept. How do we know that 2 isn't the y-intercept? Because it has the power. If you have a power, you are b. And if there's no other number, we know that it is a 1. So y-intercept of 1, y-intercept of 1, we saw it mathematically as well, right? Right there. Okay, and I'll come back to the calculator part with this question. What we're going to do here is rewrite g of x in the form of, change this, I don't know what she was thinking with that, to this. A times b to the x. So g of x is going to become h of x. We're going to rewrite this somehow to make it look like that. In other words, it's not going to have a negative exponent or anything. It's just going to have an x up there. And we did a problem similar to this yesterday in example 4. If you remember, we reviewed all the different properties of exponents, and one of them was if you have like bases, you add your exponents. So the one that we were given right here was b to the m plus n. It was this, and we worked backwards and wrote it like this and then simplified, okay? So this was addition. This one is multiplication. That's not negative 2 plus x. This is a different exponent rule. You might remember this exponent rule from yesterday is b to the m to the n. It's 2 to the negative 2 times x, right? When you put those together, it becomes multiplication. And that's what we have here. We're going to work backwards, just like we did yesterday. So g of x is what we're given. I'm just rewriting it. And I can rewrite that as, let's work backwards, do the 2, I'll try to do a different color, 2 to the negative 2. That would be my b to the m to the n power. That would be an x. These two mean the same thing. Right? Work backwards. If I gave you this and I said simplify it, you'd go, oh, power to a power, I multiply, and I would get that. And then let's simplify that one more way to make h of x. 2 to the negative 2 is what? Quick way of doing it, guys. 2 to the positive 2 is what? What's 2 squared? 2 squared is 4. If the exponent is negative, it puts it in the denominator. Let me remind you, 2 to the negative 2 is the same as 1 over 2 to the positive 2. Remember, cross the fraction bar changes the sign of the exponent, which is 1/4. So this would be 1/4 to the power of x. Are the parentheses necessary? Yes, okay? Because this x goes to all of the b value, okay? Just like it was 2 to the negative 2 is written like kind of more compact, now it's written as a fraction, you have to have parentheses, okay? So remember, anytime you have a negative exponent, think about what is the answer without the negative and then put it in the denominator. It's that quick, okay? And then, so what this last part is asking, what is the y-intercept of f of x, g of x, and h of x? Well, we already just talked about what the y-intercept of f of x and g of x is. It's 1. We saw it on the graph. We see it in the xy chart. We know it because of this. Well, we should know also that there's a 1 in front of this guy, so the y-intercept is 1. Plus, these two are the same. They're the same thing written two different ways. So the graph is going to be the same, okay? Now, all of that we did by hand, okay? And when I say by hand, we're just doing the math in our head. Oh, okay. Would one of you two in the middle row move to the back, and then she can have that whole row? Like, Dan, would you mind just moving back? Chase, move over, and then Jocelyn can have those 3 seats. Thank you for being wonderful. Thank you, thank you. If you're watching this video, we just had some shadows come in. So we're pausing for a moment. Give me a second to get them settled. Jocelyn, we're on page 36. Okay, so what I just said is we did all that by hand. How do we do these in the calculator? When you get to the homework, if you don't want to have to plug and chug, especially when you have these numbers up here, your dilations, a really easy way to do it is go to y equals, like I'll type this one in, 2 to the power of negative 2x, okay? And I'm going to get the same numbers right here when I go to my table. You don't have to hit graph first before you hit table. You can go right to the table, which saves you a little time. And so if we want negative 2, there's my negative 2, 16, 4, 1. Oh my goodness, what are these? Remember, a lot of you talked about this with me yesterday. Your graphing calculator is going to give you the decimal version of your answer. That's totally fine. You don't have to write this as a fraction. It's just easier to do it as a fraction by hand because you're just flipping these numbers. But if you wrote 0.25 and 0.06, totally fine. What does that mean on a graph? Well, you should know that those two numbers are less than 1. So those little baby numbers close to your asymptote. Okay, so that's why I'm saying it doesn't matter if it's a fraction or a decimal, and I don't care when you get to the homework whether you use the graphing calculator or your brain to do the arithmetic, as long as you know how to do both ways. Okay, that's what's important. Questions on that before we go into the next one? We did one just like this yesterday, I think the same example. So I'm going to skip example 7 and do one like it with a different graph, which is example 8. So now we're on page 37, example 8. Okay, more graphing. Graph f of x, graph g of x on the same coordinate plane, and then we'll answer some questions, okay? So in this problem, guys, when I'm trying to decide, do I want to pick up my calculator and do it, or do I want to do it by hand, that's going to be a personal choice for you guys as far as working on this stuff. But again, there are times when you don't have a calculator and times when you do. I think I'm going to practice doing it by hand with you because I think that's harder. If there's one of these ways that is hard, it's the harder of the two. So let's just practice it. So I'm making an f of x table of values here, okay? So I'm just going to plug and chug right through here. Again, anything to the 0 power is 1. 1/3 to the first power is 1/3. And remember, we talked about this property yesterday. The 2 applies to the numerator and the denominator. So that would be 1/9. And remember, all you have to do is flip these. That's 3, that's 9. And when I say flip, I don't mean change the sign. I mean literally flip the fraction, the reciprocal. Okay? We have a k value of 0. So our horizontal asymptote is at y equals 0. And then I'm just going to plot these points. -2, 9, -1, 3. There's that y-intercept, which we should have already known because a is 1. And then our little baby numbers. Whether they are fractions or decimals, we know they're just little numbers between 0 and 1. So we just estimate them. Here is f of x. So just comparing to the way we did the last problem, same thing. We had f of x and g of x, and we had to put them both in the same coordinate plane. I decided to actually do the math on this one because of the dilation. This one, there's no dilation. This is translations, right? Shifts. What does the -4 do to our graph, guys? What direction do all our points go in? Right. Remember, it's opposite up there. When it's up with the x, that's your left or right. And then the +2 would be up 2. Remember, your vertical translations are not opposite. So all you have to do is go right 4 up 2, right 4 up 2 with all these points. And by the way, you can switch that. You can go up and then right. It doesn't matter, whichever one you want. So when I go right 4, 1, 2, 3, 4, up 2, I'm going to be off the graph. Fine, who cares? Okay? And then I'm going to do the same thing to this point. 1, 2, 3, 4, 1, 2. And then this point. Oh, wait, I forgot to do something. Let me back up for a second. Before I continue the graph, nothing's wrong. I just want to do something first. I want to put my asymptote on here first. And since this is my K, I now have a new asymptote. So if your points move up or down, your asymptote moves up or down. So now we have one at y equals 2. And the reason I stopped myself at that moment was as I was getting closer to my little baby numbers, I knew I wanted my asymptote there to help guide me, as you're going to see here in a second. So here I went right 4 up 2 for my first 2 points. Let's keep going. 1, 2, 3, 4, 1, 2. And see, now that I have my asymptote here, I just know they're going to be really small numbers getting close to my asymptote. I don't really have to measure them out or anything. And there is my g of x. Okay? Find the y-intercept of g of x. Well, we already know the y-intercept of f of x is 1. G of x clearly is not 1. It's going to be somewhere way up there, right? Up and to the left where it's going to cross the y-axis. And I'm not going to sit here and do all of those points. I'm going to do it algebraically. So let's back up for a second. We just talked about how the a value is your y-intercept, and a is technically 1 still in our transformed graph. But we are now, think about it should make sense to you that when you move all your points left, right, up, and down, your y-intercept is going to move. So we can only call a our y-intercept when we're written in this form, okay? So how about this? Let's do it algebraically. What is our x value when y, on any y-intercept? What would the x value be? What is the x value of every single point on this line? 0. So can't I just plug 0 in for x and solve for y? The answer is yes, I can. And I'll do this in my calculator. 0 minus 4, of course, is negative 4. So when I put a fraction in my calculator, remember on these calculators, I need to put my fraction in parentheses. If I'm going to do something to that fraction, it needs to go in parentheses. And I am. I'm going to do 1/3 to the power of negative 4. Hit enter, plus 2, enter. So my y-intercept is 0.83. Like I said, way up there. So sometimes you can just tell by looking at the graph. Sometimes you can tell by looking at the function. Sometimes you can do a little bit of math. And what were the transformations from f of x to g of x? We already said it. Right 4 up 2. Written very ineloquently, but gets the job done. Okay? I'm going to do another graphing one with you in the homework. Let's do our last example now, which is example 10. You sure you want to miss this last example? Okay. All right. Example 10. These should be freebies for you. What we're about to talk about in this is something you've done a million times, not just in this class, but Algebra 2, Algebra 1, and that is, what do these symbols mean to the graph? All right, yesterday on page 35, remember we went through all the different types of transformations and then what it looked like in an exponential function. So, for example, a horizontal translation is always sequestered off with the x, like in parentheses, or up in the power. That's all we're talking about here. So what we're doing is taking f of x and creating a new equation. So in this first one, we're going to create a new equation called g of x, which will be f of x with this done to it. It's being able to read the language. What does this symbol mean? So we're going to have 4 to the x minus 3. That's how we show right 3 in an exponential function. Okay? And it says to describe the transformations. Again, I'm going to make these nice and short. We could write it all out in nice flowery words. G of x is f of x translated to the right 3 units. And maybe if this is an FRQ, we'd want to do that. But just for our homework, we can just write it nice and quick. Okay? What letter? So this was H, right? Negative 3 was your H. What letter would you say 5 is? It's the K, right, Sam? It's K, right? It's the number all the way to the right. It's your horizontal asymptote. This is going to be our h of x graph going 4 to the x, and then we always put it right on the ground at the very end. H is up in the air by itself with our x value in the exponent. K is on the ground at the same level as the base, right? And that just means up 5. You can write it all out, like I said, or you don't need to. Again, in little parentheses, that's where we are doing something to the exponent here, right? Just like here, this was right 3. This is a dilation by factor of 1/2. So k of x would be 4 to the power of negative 2x. You can put negative 2x in parentheses or not. It won't make a difference. Either way would be fine. Now, guys, be careful right here. This one, when we have to describe it, is one that students get wrong all the time. There's actually 2 transformations there, the negative and the 2. They're 2 separate ones. That negative is flipping over which axis? The what? Y-axis. Yes, it's opposite of what you would think. Remember, everything that's being done with x is wonky, like it's backwards, right? We do right 3. We're actually flipping over the y-axis, and it's a horizontal dilation by, you can say factor of or just by the number, by 1/2. Remember, you have to do the flip there. Remember, it's flipped. If you need to go back and look at the notes, they were on page 35. Okay. Last one till we get to the homework. P of x. So this would be my A, right? Negative 3 in parentheses, or you could use the dot. There's my base of 4, right there. We would have the x plus 1 would go up in the exponent, and then the minus 2. So there's my h and my k. What's going on here? Zach, this one would reflect over the what? X-axis, right? Like a parabola. A vertical dilation, I'm really abbreviating now, by 3. Remember, we don't change it. It's not 1/3 when it's vertical. It's not never will you have a negative dilation. 2 separate ones, right? Negative and 3, 2 separate ones. And then left 1, down 2. I think we know those. Okay, and you can write them in any order. It doesn't matter. Good? Good, good, good. All right, I'm going to do number 1 with you. Are you still writing, Jaden? Oh, sorry. That's what you were saying. All right, I'm going to do number 1 with you. This is where I'm going to do number 1 by hand. If you want to do the other ones with your graphing calculators, that's totally fine. But let's get started. So, like I said, I'm going to do this by hand. So I'm going to do an XY chart for f of x. Remember, we always use those same starting points. We can add more if we want to, up to you. Anything to the 0 power is 1. 1/2 to the first power is 1/2. Again, you can use decimals or fractions. And then 1/4. Flip on. We'll have a y-axis asymptote, x-axis asymptote. Let's label the x-axis, or the x-intercept. If we have it on the graph, let's label it. And it's nice on the graph. I don't care if you plug in 0, find the y-intercept like we did. So here is where you make a decision. Am I going to make a new xy chart for g of x, or is this one easy to just move? This one would be easy to move, right? This is -3 is what direction? Right 3, and this would be down 2. remember, K is my new asymptote. If I'm moving all my points down 2, my asymptote moves down 2 as well. So I have a new asymptote. So I'm just going to take each of these points and go right 3 down 2, or the whole numbers anyway. And it's okay if you touch the other graph's asymptote, okay? I'm touching the purple asymptote here. It's okay, because I'm just not going to touch the red asymptote. And then the numbers get really small here. So that one was easier to do all by hand, in my opinion. We labeled the asymptote and the y-intercept of the one we had. This y-intercept's going to be way up there. Actually, it's 8, but we don't have it. But let's talk about the domain and range. These are really, really easy, okay? So for f of x, let's do domain and range. Let me just make this really easy for you guys. The domain of all exponential functions, no matter what you have done to it transformation-wise, is all real numbers, okay? And range is affected by your horizontal asymptote, right? So my purple graph, which is f of x, had an asymptote of 0. So it's everything above 0, right? Not including 0, so you must use parentheses. And then for g of x, again, domain is always going to be all real numbers. You don't have to look at the graph. You don't have to look at the equation. It's always going to be all real numbers. And the range in this case would be what? 2, no, Zach, 2 to infinity, right? You said something about negative infinity, I thought. That would be the numbers below this. That would be if this was down here. Then you'd say negative infinity 2. But this is from 2 to infinity, okay? You should see your asymptote. Oh, yeah, it is. Sorry. But wait, Zach, didn't you say negative infinity? Okay, thank you for being honest. I knew I heard a negative somewhere in there. Yeah, I should have put a negative 2 there. But yes, negative 2, but still to positive infinity. Thank you for catching that. Okay, so that's how you're doing those. Again, I did not put the XY charts on the homework. You can write them out. You can just do them in your calculator. It's up to you. Yes, yes. I put the key on Canvas, so if you have your laptop, and because there's a lot written up here, if you want to pull out your laptop and look at the key, you can. I already uploaded it.